Welcome to the next module. In this module, we will be covering statistical questions. Statistics is the foundation of data science. The more that I have learned about data science, the more I have realized that fundamental statistics knowledge is an essential skill to be successful in data science. With the same reason, statistical questions are one of the core part of a data science interview. Be it the role of data analyst, business analyst, data engineer, data scientist, you can always expect statistical questions. Without wasting much time, let's go in the depth of statistical questions. In this video, we would be looking at what types of statistical questions are asked in a data science interview. The first set of questions are about probability. These questions won't necessarily require complex mathematics. The next set of questions are about distributions and sampling of the dataset. The knowledge of distributions the data follows is very important for modeling perspective. An example for it would be linear regression works very well when the y variable is normally distributed. The next set of questions are about data exploration. Data exploration is an approach similar to data analysis, whereby a data analyst or a data scientist uses visual exploration to understand what is in a dataset and what are the characteristics in the data. The next set of questions are about descriptive statistics. Descriptive statistics help describe and understand the features of a specific data by giving short summaries about the sample and measure of the data. When I say feature, I mean the column. The last but not the least are statistical significance tests. These are used to test various hypotheses and test the statistical significance of a model. These are the key types of statistical questions. You might expect different types of statistical questions based on the job profile. In this video, we will be looking at why are statistical questions asked in a data science interview, or why statistics is an important part of data science. Companies often find themselves having to deal with massive dumps of data from a panoply of sources, each more complicated than the last one. Statistics can help to spot anomalies and trends in the data, further allowing researchers to discard irrelevant data at a very early stage instead of sifting through data and wasting time, effort, and resources. Statistics aids in data visualization and extracting insights out of the data, which might be a game changer for the business. Statistics facilitates statistical modeling. Data is made up of series upon series of complex interactions between factors and variables. To model these or display them in a coherent manner, statistical modeling using graphs and network is the key. This also helps to identify and account for the influence of hierarchies in global structures and escalate local models to a global scene. Statistics aids mathematical analysis and it reduces the assumptions. The basics of mathematical analysis, differentiability and continuity, also form the base of many major ML and AI algorithms. Neural networks in deep learning are effectively guided by the shift in perspective, that is differential programming. Because of the above stated reasons, statistics is a core part of data science. Let's start with the questions. The first question is, what problem multicollinearity might cause to a regression model and how to deal with multicollinearity? I'll pause here for a moment, see if you know the answer and try to attempt that. Let's start with the answer. Multicollinearity exists whenever an independent variable is highly correlated with one or more of the other independent variables in a multiple regression equation or a multiple regression model. Multicollinearity is a problem because it undermines the statistical significance of an independent variable. It can increase the variance of the coefficient estimates and make the estimate very sensitive to minor changes in the model. The result is that the coefficient estimates are unstable and difficult to interpret. There are multiple ways to deal with multicollinearity. One way is to remove some of the highly correlated independent variables. Start removing these variables one by one. Another way is to linearly combine the independent variables, such as adding them together or subtracting them. Another way is to perform an analysis designed for highly correlated variables, such as PCA, that is principal component analysis, or partial least square regression. So these are some of the ways in which you can deal with multicollinearity. There are a lot of other ways as well, but I'm not covering those in this video. This is how you should answer a question. You should add correct technical details to the answer. Let's look at the second question. The question is, what is a confidence interval and how do you interpret it? I'll take a pause here, see if you can attempt it. Let's look at the answer. A confidence interval is how much uncertainty is there with any particular statistic. Confidence intervals are often used with a margin of error. It tells you how confident you can be that the results from a poll or survey reflect what you would expect to find if it was possible to survey the entire population. What that means is, you survey or take poll from a smaller sample of population, maybe 40 people, 50 people, or even 100 people. How much confident you can be that the statistic you noted now is a true representation of the overall population? Let me put it in bit technical terms. A confidence interval is a range of values that likely would contain an unknown population parameter. Now let's look at how to interpret confidence interval. We'll take help of an example. Here, the problem statement is that we want to find the average height of a population. So, we chose 40 people randomly and then we noted their height. The mean of the height was 175 centimeters and the standard deviation came out to be 20 centimeter. And the given confidence interval is 95%. Now we need to understand what does this 95% confidence interval means. The first step is to convert the 95% confidence interval in terms of the height. The conversion of 95% confidence interval in terms of height would be 6.2 centimeters. So, the 95% confidence interval means that the true mean of all men, that is all the population, is likely to be between 168.8 centimeter and 181.2 centimeters. You must be thinking, where did 168.8 and 181.2 centimeters came from? So here I have subtracted 6.2 from the mean and I have added it to the mean. So 95% confidence interval states that 95% of the experiment like we just did will include the true mean, but 5% won't. Let me put it in simple terms that there is 1 in 20 chances that our confidence interval does not include the true mean. That is, if you repeat the same experiment 20 times, out of 20, 19 times you will expect the mean to be in between 168.8 and 181.2 centimeters, but there would be one chance where the true mean will not be between these values. So this is how you should answer a statistical question. You should add a proper example to it. Next, I'll show you the practice problem. Welcome to the final video of this module, that is practice question. The question is, what is the 68% rule in normal distribution? Give it a shot. With this we come to the end of statistical questions module. I hope now you will be able to attempt statistical questions.